All right, ladies and gentlemen, welcome back to another video with Mr. Kenton for physical science. And now that we've talked about the history of the periodic table and looked at kind of an intro to what we're going to be looking at in the periodic table, we can now start to look at what are some of those patterns. Now remember, the word periodic and periodic table means repeated in a pattern. What are some of those repeated patterns that we can identify? Now, in order for us to do that, we're going to have to break down the structure of the periodic table itself. And so when you look at the periodic table, it consists of many columns and rows, okay? And so let's first deal with the columns that are on the periodic table. And so the columns, those are those vertical columns that have your elements in them. And these are commonly referred to by chemists as groups or families, okay? Now, again, these are the vertical columns on the periodic table. And the reason why that they're called groups and families is because the elements in these groups or families are similar to each other, like members of a family, right? Obviously, they have their own unique differences that's unique to that individual element, but they share some properties that at the core of those particular elements is the same for every single one of them, okay? Now, if you look at the periodic table as it's currently constructed, there are currently 18 columns on the periodic table, which can then be broken down into 9 families, okay? So of those 18 columns, that breaks down into 9 different families, or 9 different groups. So that means that you have 9 sets of elements that are going to share some characteristics with each other, okay? Now, the big thing that a group or a family is going to tell us is that obviously they have similar properties, whether those be chemical or physical, which is unique, but also a big thing here is that elements in the same group or family or in the same column have the same number of valence electrons, okay? And I'm going to get into valence electrons a little bit more here later, but just know for now that valence electrons, if you remember from Bohr models, those are the electrons that are in the outermost ring or outermost energy level of an atom. These are really important because these are the electrons that are important in bonding. Now, in some cases, when we start to look at these families and columns, some of them do have special names so that you can distinguish elements from the other groups, and you can commonly see chemists use those names when referring to elements on the periodic table. And so, as we move forward, we're actually going to look at what are some of those particular names of these groups or families that chemists have given to elements on the periodic table. All right, so if you look here, your vertical columns, this is going to be, if you're noticing, goes all the way from 1 to 18, so as you're going left to right, and your columns would be, like you have the orange column, the green column, you got the yellow columns, you got the white column, the pink column, the kind of bluish column, you got that like, I don't know, best color column 16, and then you got column 17, you got column 18, right? And if you notice, the colors correspond to the groups or families. And so based on whatever color you see, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go, you got those 9 families that we were talking about, those 9 groups. Now, as we mentioned previously, elements in the same family have similar properties, and they have the same number of valence electrons. So all of the elements in column 1A are going to have similar properties and the same number of valence electrons. All of the elements that are in green in column 2 or group 2A are going to have similar properties and the same number of valence electrons. And we can apply that moving forward for the columns that are yellow, for the columns that are white, pink, blue, so on and so forth. All of the elements that are in a particular column are going to have those similar properties and the same number of valence electrons. Now, as I mentioned, there are some very specific names for some of the columns. Now, these names are important But I'm not going to be testing you guys on specific names of groups of elements, but I do want you to have just in the back of your mind, like if I use the term for a group name, I want you to at least be able to remember and say, oh, Mr. can talk about some of them had specific names. And so these are just some of those specific names that you should be aware of. So group 1, that'd be our orange column. Those are known as the alkali metals. Group 2, which would be that green column, those would be the alkaline earth metals. Groups 3 through 12, so that makes up those yellow columns on the periodic table. Those would correspond to the transition metals, excuse me, on the periodic table. All right, your white column, which is group 13, that's going to correspond to the boron family. Group 14 or 4A, that's going to be the carbon family. That'd be the pink column. Group 15 or 5A, that's going to be the nitrogen family. Group 16 or 6A, that would be that column that looks kind of like, I don't know the best, it's like a deep purple, a darker purple. That's the oxygen family. Group 17 or 7A, that's kind of your light purple, your lavender. Those are the halogens. And then group 18, which is the red column, corresponds to the noble gases on the periodic table. And so again, all the elements in the alkali metals have similar properties, and they have the same number of valence electrons. And then we can apply the same principles for all of the elements in each of those columns. Now, let's talk about those valence electrons, because it's being mentioned, and like I said earlier, that I wanted to revisit this. So valence electrons are the electrons that are in the outermost energy level of our atom, right? And so if you remember in the previous unit, I had you guys draw Bohr models for the first 18 elements on the periodic table. And what you had to do is you drew rings to represent locations where electrons could be, right? And so you had the first ring, which could hold 2 electrons, and then you had the second and third rings, which could hold up to 8 electrons, right? And so ultimately, when you look at an element, that outermost energy level, that outermost ring, those are the electrons that are most responsible for bonding during chemical reactions. And so when you look at an element that's in the same group, they all have the same number of valence electrons, right? Now, a pattern that we see as we move from left to right on the periodic table is that the number of valence electrons for our atoms is going to increase as we go from left to right. Now, keep in mind that the maximum number of valence electrons that an element can have is 8. Elements cannot have more than 8 valence electrons, okay? So again, just to kind of quickly recap here, you've got your valence electrons. By definition, these are the electrons that are in the outermost energy level of our atom. Think about the outer ring in our Bohr model. These valence electrons, these are what are responsible for chemical bonding in chemical reactions. Our columns, so for example, our alkali metals, for example, have the same number of valence electrons being 1. Okay, and that we see a pattern that as we move from the left side of the periodic table where we start with the alkali metals, and as we move across to the noble gases, the number of valence electrons is going to increase by 1 as we move over, right? So the alkali metals would have 1 valence electron, our noble gases would have 8 valence electrons. And again, the maximum number of valence electrons you can have is in fact 8. Okay, now breaking this down, just to state it very clearly, group 1 or 1A, you can look back at the image that was on the 2 slides ago with the periodic table with the color-coded columns. Elements in group 1 or 1A have 1 valence electron. Elements in group 2 or 2A have 2 valence electrons. Now, where this is really important to pay attention to is notice that it skips 3 through 12. And if you look back at the image, those were the 3B through 12B groups. We skip those and we jump to 13 or 3A, which is the boron family. So group 13 or 3A elements have 3 valence electrons. Group 14 or 4A elements have 4 valence electrons. Group 15 or the 5A elements have 5 valence electrons. Group 16 or 6A elements have 6 valence electrons. Group 17 or 7A elements have 7 valence electrons. And group 18 or 8A elements have 8 valence electrons. And so again, we see from this particular information that as we go from the left side of the periodic table all the way to the right-hand side of the periodic table to the noble gases, we see that that number of valence electrons is increasing by 1. Okay. Now, if you're wondering, the elements that are in the 3B to 12B groups all have the same number of valence electrons, which is 2, which matches up with the group 2 elements, right? But so all of the transition metals have 2 valence electrons. Okay, so kind of keep that in mind moving forward. All right, so I've given you guys some information. Here's what I want you guys to be able to do, right? So we've talked about just simply based on a group number that we can determine the number of valence electrons that an element has. And so what I want you guys to do is I want you to find each of these elements, strontium, sodium, nitrogen, neon, and lead. And what I want you to do is I want you to identify how many valence electrons these elements have. Okay, I'm going to be posting a Google form on Google Classroom that'll be near this video, so you'll be able to complete that so I can get some feedback and I can know, did you really understand how many valence electrons and how we can figure that out. Okay, so take maybe the next 2 to 3 minutes. You can pause the video, go complete that Google form, and input just how many valence electrons each of those elements have. Okay. All right, so hopefully you paused the video and you took the time to fill out that Google form for the valence electron practice. So the next thing that I want us to take a look at are the horizontal rows or the periods on the periodic table. Okay, and so again, tried to provide you something to give you kind of that perspective of what those rows or periods are referring to. So notice that there are 1, 2, 3, 4, 5, 6, 7 different colors that you see in that periodic table on the bottom, and the colors are changing as we move rather than going left to right as we're moving down, right? So in row 1 or period 1, you got the elements in orange, row 2, the elements in green, row 3, elements in purple, row 4, elements in red, 5, light blue, 6, yellow, and 7, dark blue. Okay, so those horizontal rows are commonly referred to as periods by chemists. Now, the period number, so that number that's on the side, 1 through 7, tells you how many energy levels there are in an atom. So I want you to think back to your Bohr model. This is going to tell you how many rings your atom needs to have so that it can hold those electrons appropriately. Okay. Now, the number of energy levels increases as you move down, right? As you move down your column. So row 1 has 1 energy level. Row 2 contains 2 energy levels. Row 3 contains 3 energy levels. Row 4 contains 4 energy levels. Row 5 contains 5 energy levels. Row 6 contains 6 energy levels. Row 7 contains 7 energy levels. Now, unlike with groups or vertical columns, elements in the same period do not have the same properties. This is because elements in the same period do not have the same number of valence electrons, right? Because as we move from left to right, we see an increase in the number of valence electrons that our elements have. All right. So that's pretty straightforward. That's all I wanted to talk about with regards to rows and periods. And so the last thing that I want you guys to be able to do again, to just practice what you heard as you've been taking notes here. I've given you the same list of elements, and I want you guys to identify, because you should have already found these elements, how many energy levels do the following elements have? You know, how many energy levels does strontium, sodium, nitrogen, neon, and lead contain within their particular atom? Okay, and remember, you can use the row number to help you figure that out. All right, thank you guys for joining me. Please go complete those Google Forms on Google Classroom, and I look forward to seeing you guys again real soon.